Intelligent performance with DSS specifics. Having the monitored data, the next natural phase is to use it in order to measure the performance levels of the DSS, consequently allowing the assessment of its efficiency. There are several particularities that render the process more delicate than for operational systems. We make a presentation of the most notable DSS particularities, as taken from Inman, 2005. The data warehouse is the heart of a DSS, and represents the architecture used for storing the analytical data. The core of data warehouses is the data mart, which is a repository of data gathered with the help of ETL software from operational data and other sources, with the purpose of serving a particular community of knowledge workers, SAP, 2010. Metaphorically speaking, data marts are the bricks that are used to construct the data warehouse building. Inman identifies four main considerations for making the separation between the analytical and operational data. I. Analysis data is physically different from operational data. 2. The technology used for operational systems is fundamentally different from the one used with DSS. 3. The processing characteristics for the two are different, and 4. The analytical and operational communities are two different worlds. DSS are subject-oriented, with the goal towards business objectives, whereas operational systems are application-specific, focusing on application requirements. That is why measuring the performance of a DSS is harder, as it is based on user expectations. The resource utilization patterns of DSS are completely different from the ones of operational systems. There is a notion of time relaxation, as data warehouses are not used constantly with the same load. There are periods of maximum load, which are also known as critical periods, and periods of small load or inactivity. For example, a budget planning application will only be used the first week at the beginning of each month, thus requiring the maximum of available resources during this period only. The other 3 weeks, it can function with the minimum needed resources. We identify two major criteria for the distinction of the utilization patterns: I. The utilization periods, and 3. The utilization purpose. The utilization periods reflect the critical periods and are usually specified with the SLAs. The performance objectives per utilization period and per user type, alongside the specification of the critical functioning periods, are regular elements of the agreement documents. The utilization purpose formalizes the two main data cycles of the data warehouse: I. The usage of the data for the generation of reports, and 2. The recalculation of the data for data warehouse update. They are also known as the day, production, and the night, batch, usage. During day, users access the various data from the data warehouses in order to build analysis reports, which help them with the process of decision making. The data warehouses are exposed to intense data retrieval operations. Even if the response times are very small, for example 80% of OLAP queries must be under a second, Codd et al., 1993, the user activity is very high, even thousands of users. During night, batch operations are executed to integrate the new operational data, from the day that has just passed, into the data warehouse. The executed calculation and restructuration operations are very resource and time consuming. Moreover, the new data must be integrated before the start of the next day in order for the users to have the correct reports. One last DSS characteristic we want to discuss here is the motto of the decision expert: give me what I say I want, so I can tell you what I really want. Inman et al., 1999. This expresses the fact that data warehouse users access a large variety of data from the data warehouse, always being in search of explanations over the observed reports. Therefore, anticipation and prediction of the requested data usage or system charge is very hard to implement, leading to, not necessarily a good thing, more relaxed performance requirements. Performance measurement with DSSs brings into discussion, along the technical aspect, from operational systems, the user satisfaction aspect, form the business objective-oriented point of view of analytical systems. There are two main types of performance, Agarwala et al., 2006. Raw technical performance related to the technical indicators for measuring system performance, such as response times for recovering data from the data warehouse, report generation, data calculation, etc. Objective performances relating to user expectations. These measures are based on predefined policies and rules that indicate whether or not satisfactory levels are achieved by the system, for example response time relative to the importance of the data warehouse or with the user activity. Retaking the example shown by the authors of Agarwala et al., 2006, a detailing of the COES formula is shown below. And the basic single parameter COES is computed by the ratio between the monitored values and the specified expected values. If several parameters are responsible for a global COES, then a scaling factor is multiplied with each individual COES, and, in the end, an average of all the scaled COES is computed to obtain the overall system COES value. The data warehouse quality model is goal-oriented and roots from the goal question metric model. Whether metrics satisfy or not the goal determines the quality of the data warehouse, Vassiliadis et al., 1999. Data warehouses must provide high COES, translated into features such as coherency, accessibility and performance, by building a quality meta-model and establishing goal metrics through quality questions. The main advantage of a quality-driven model is the increase in the service levels offered to the user and implicitly increase in the user satisfaction. COES specifications are usually described by the SLAs and the SLOs. We have seen what SLAs stand for. In a similar manner, SLOs describe service objectives, but on a more specific levels. For example, a SLA would describe that an application is critical on the first week of each month, whereas the SLO would state that during critical periods the query response time on the data marts used by the application should not be greater than once. With DSSs and data warehouses, one important area where service levels are crucial is the utilization periods, in direct link with the answer to the question, what is used, by whom and when. Data warehouse high charge periods are specified with SLAs. When building a new DSS and putting in place the data warehouse architecture, the utilization periods are specified for the various applications. To paraphrase a study from Oracle, the key to enterprise performance management is to identify an organization's value drivers, focus on them, and align the organization to drive results. Oracle, 2008.